Hello guys, welcome to this tutorial. In this video I'll be talking about pixels and why should you guess a pixel or certain pixel when you're doing patterns or when you're generating seamless patterns, vector or raster. So in this video I'll be using CorelDRAW, one vector program or vector oriented program to illustrate or demonstrate pixels, and Photoshop to demonstrate raster illustration of pixels. So in Corel, if you don't have Corel, you could download Corel from the Corel website. I'll also drop a link for you to get Corel. Not necessarily, you don't really need the software, but if you wish to have it, you could just download it there. But I just want to give you the general explanation on pixels and how pixel works. So in case you're going to be working with, though if you're generating images, you work with pixels mostly, so you know how to tweak values and how to work your way around pixel. In Corel, I'm going to show you something. Just go file and press new. So I click new. I have this name, custom preset destination size, custom pixel width, height. By default, this is what I'm getting, but in most cases you might get a 3000 by 3000 or 2500 by 2500. You might just get a square based or A4 type of dimension. So these rectangles you see here, these tabs, this is the size of what type of A4 paper you'll be printing on, say A4 or what type of paper you put on, rather A4, A3, A1. There are so many different types of paper and their format based on what you want them for. So if you choose custom, that means you're trying to define your own length and width of your printing card or paper, or where you're going to be placing your output. And here you've got the width, you've got the height. Basically, if you're working with images, you should go with pixels. Once you're working with images, to go with pixels. But if you're doing something like a greeting card or flyer, so you could choose pixels later on, but you might want to like fix in the dimensions first. Let's say you measure with your ruler and it's 1 inch and the height is 27 inch first, then you are good. You know, okay, it's okay when you are printing, you don't have faults before you switch to pixels to get its equivalent. So that's it. So you first switch to whatever unit you're using to take your measurement from, the physical or hard copy of that which you're trying to replicate on your system. Then if it's in millimeters, if you're measuring in centimeters, you just put them here, use your ruler, measure it, then you fill in your data here. If you're measuring in centimeters, and let's say it is 50 centimeter by 100 centimeter. Once you know, okay, this is what it is in real time, then you change it to pixels, so it will convert it to pixels, so you work with this. However, I'm saying pixels because most vector images, they are pixels, but they don't actually present themselves in pixels format until when they are converted into raster. Then you could actually see it, just because vector are like SVG, they are scalable. So that's how it's like. They are very scalable. They retain their quality even at a very large when when you zoom into a very large extent, they could still maintain their quality. So at this point, it is primary mode for RGB or CMYK. This is for magenta, yellow, black, and 2 modes. Some of these 2 modes, they differ when you print a type of printer you're using when you're printing on color formats. And here PPI stands for dot per inch. That means let me go to inch. I'm going to do this inch, and I'm going to take 1 inch and 1 inch. So in this case, if I say 300 resolution DPI, And what it's going to do is I'm going to do, let me write paint. If I choose 300 dpi, so 300 dpi, sorry about my writing, 300 dpi, 300 dots per inch, 300 dots in every inch. So 300 dots per inch will be equal to 300 times, we have 1 inch in our width, 1 inch as our height, so 300 times 1 inch is equal to 300 pixels. If I convert it to pixels, 300 pixels per 300 pixels per 1 inch. So it's going to do, if I change this to pixels, it's going to do 300 multiplied by 1 inch, so it'll be 300 times 1, that is 300 pixels. Same thing for here. So when you check and you choose pixels, you have 300 and we're going to 300. So if you're going with a resolution of let's say we are going to use 72 dp, one's the lowest here, is in 200. Once you put 72 dpi and you trying to convert, if I write 72 dp and I write 72, it's going to take it back to 1 inch. That's 1 inch. So that's it. Whenever you're doing and you're working with pixels, let's say finally you're taking it into 3D format and you want to render and you're seeing resolution and pixel, you don't know what percentage is, you could do your math so that when you render, so when you rendering, the rendering time is slower and you don't waste render time doing something that, or you're rendering something that even at a lower rendering, like if you are rendering if you're rendering an image that takes you 4 hours and you're still going to get that same quality if you render it in 1 hour, you rather render it in 1 hour than rendering 4 hours. So with this guide, basically you could know the number of pixels you're dealing with, the number of resolution that you need, and what device you're going to be using that image for, instead of wasting time or going out of time. Because once you start going further in rendering and you're doing complex scenes, you'll be needing more rendering time because of how cool and how aesthetic you need your scene to look like, or whatever you're doing to look like. So whatever you're going to do, you're working with DPI. Most of you use DPI in, you can see them in devices, let's say phone screens, they have dot per inch. That's on phone, they are more brighter than other phones. Some phones they could what 360 pixel movies, 720px movie, you have them, and the likes. So in this case, mostly I use 300 dp, and then I do 300 dots per each inch. And if I'm measuring my inch, okay, fine. I don't measure any, but if I'm measuring a card that has 2 inch, if I use my ruler, I measure an inch. But if I'm doing a card, I know I'm working with the pixels, so I'm going to be using this resolution in case of anything. But if I'm going to work, I'm just going to go to pixels and I write the pixel that I want. If I'm working with 1980, 1920, 1080, this is by default 4:3. Yeah, I think it's 4:3. 4:3. I'm just going to calculator. 4:3 aspect ratio 1920 as 1.8 divided by 1080. So 1.78. 1.78. I do 4 divided by 3. 1.33. Alright, fine. Then there are other dimensions like 1280 by 720, so 1778. So this is like an aspect ratio that you use when you're trying to increase the size. Just that this is nice. You can use any kind of aspect ratio you want. Yeah, it depends on where you want to use it. But on YouTube, they use 1.78 on most devices and system laptops. 1.78 on phone, you have 720 pixels, so you have to convert it below. You take it down 360px, you take it down. See, So if I choose this 192.1.0.0, we're going to have 1920 boxes that we can store each color for our width, and we're going to have 1080 boxes that will store every color for the height. So I check, okay, I don't want to go this high, maybe I'm just going to choose 50 because we're not going to count one. We go like 10, yeah, 10 pixels, 10 pixels. Now 10, you can go 10 for here. 30 pixels, 30 pixels, 10, 10, right? 10 pixels, 72. I check OK. So you see, I have to zoom in. Yeah, the maximum. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 10 boxes here and 10 boxes here. So each of these little boxes will contain a single color, not a blend of two colors. A single color. That's what it's going to take. We take a blend when it gets into raster, but when you going out of it, you're going to get a single color that's going to represent all the mixes of any color that is in a second layer. So if I pick this box and I'm going to write this, see, this is the true color, black, light color, black. Change to white, if you change to gray, you change to, this is the true color, so it's going to be black. So these other parts that you see are just the shades of the combination that is getting from externally. Because we're doing it 10 by 10, it looks smaller, you might not see the color like that. But if I increase this to 4, you can see we went to green. That's the one we choose lastly. So you can see it's getting greener. When we take it, it gets the final green. So you can see these other smaller ones are contributing to the color to give it a true feel. We'll fill all this place with this color. So you see this is true color. So as it goes closer, it's going to take a single color and fill it in one of these boxes. Like if after all the approximation, like you did all the summing and division and getting the average of each of the colors and getting the average, like it's going inside, you still have more dark than green, and dark supersedes the green color because it's ash. So black will be replaced. Same thing, that how it goes. So you could choose a red, a pink, like that, and it goes inside if I'm darker. So that's pixels for you. And if you could change your pixels, this is correct. If you're using GIMP, works same way, but you might not have all of these features. You 100 by 100, and you have a bigger one. So even this says 100, you have 100 smaller dots up to here, and same thing from the height from here. This is like your canvas. This is where you're working on, and every color you put, this is vector. This vector have every color you put here, and that's it. When you try to do, you finish, you export your image and you use the image maybe in a 2D stuff, or you see it in a 2D program post-compositing compilation. And what else? If you download an image, I'm going to open residual, just say residual largest color wheel. I'm going to say this image is PNG format, 650 by 650. So this means 650 by 650 dimension, height and width, that is for image. And we go to properties, we go to details. You see 650 by 650 pixels by 650 pixels, 650 boxes that can be filled with a single color by 650 boxes that can be filled, and the bit depth is 24. And where you see about the resolution, you drag this and drop it here. Then this is 650 by 650. So we are using our canvas is 100 by 100. So if I take this to 650, we get a canvas that will fill in 650. So you see, this canvas will fill in exactly 650. see here 650 by 650. So that's it. You have 650 boxes. See, from this part you have 650 boxes to the end that fills in a single color. See, this color is white. This is light orange. This is mix of light orange and dark orange, but a single plane, no shades, no transition, no shades. This is a lighter one, like a 10% or a 1% addition of each color, ranging from left to right, from top to bottom. But mixed, but it's just one color. It's either you're getting a gray, you're getting a black, you're getting white, having shade transitions of colors. So that's it about pixels. The same applies to raster images. And raster images, vector, we have raster. Vectors are scalable, raster are not scalable. They can maintain their quality once you try to resize them, especially when you are increasing the percentage. So in this order, you get different. Let me say I open this image, and I'm going to do this. I'm going to go to temporary file to draw this image of your profile. I'm going to show you this it's got 300 dpi, 24 bit. It's got a resolution 200 dpi and 4374. So same here. If you raise this, see, this one is 4,304 pixels width and 3,014 pixels height. So you could, if you scale this down, you're giving it more quality. But when you scale it higher, you're reducing quality. That means, like, if you scale it smaller and if it appears in a smaller screen, like a screen smaller than its initial 1400, it's going to be brighter. But if you use it in a screen that's greater than 4000, it's going to lose its quality. Like, not that it's going to lose, it's going to be less qualitative than it was in the previous screen that we're using in viewing. So that's it about pixel and both vector and raster. I should show you in Photoshop how pixel also looks like the same. Photoshop, vector, Photoshop, raster, and CorelDRAW, Art, AI, that is Adobe Illustrator, vector, same. Pixel works everywhere. Pixel is all the same, even in Paint. Paint also got its own pixel. So that's it about the CC 82 by 578 dp, and that's a px. Take the cursor up. Right. So if you go to Photoshop, open Photoshop. If you don't have the link, you download Photoshop, Google it, and you get that. I'll drop the link as well. So you check new Photoshop. It has the same format. You see, you have the width, you have the height, you have the resolution. So same thing, pixels per inch. If I need 300 resolution, that's 300 pixels. I need a height of what? 1 inch, width of 1 inch. So 300 times 1 times 1, that is 300 display. And display of smaller dots. So you have 300 of it, 300 by 300. So I double click and to unlock this, and then I can zoom in so we can see the dots. So this is it. Yeah, this is it. See, if I remove this, we have 300 small dots from here to here, and 300 from here to here. I mean, we can just experiment with a smaller length or smaller width, and you find out that it's the same thing. Same applies to pixels in vector and also in raster. Alright, thank you guys for watching this tutorial. I guess now you understand how pixel works and how pixel is and what it looks like when you're doing rendering or you're printing images. You know how to work over your pixel, you know how to brighten issue. You know how to brighten or make a new image more enhanced, and you should know if an image has the ability to be more cool or more nice, and to tell if it's going to be okay and to use in different scenes. Alright, thank you guys for watching. Well, to subscribe my channel, and don't forget to hit the bell icon so you get notifications on every video I post every week. And see you in my next tutorial. Bye.